So in this tutorial we will discuss about 3D plots. So again it is CLC, clear all. Now we will try to create some functions for a 3D plot. So defining functions. Okay, we'll write it like this: 3D functions. So if there are 3D functions, then there should be 3 variables, right? So z is equal to, I'm taking randomly, z is equal to, let's take x square minus y square. Okay, this is one function. So let us take this as z1. So we'll take a second function as z2 is equal to, let's take it as x square plus y square. Okay, I remember one function, so we can take that also. Z3 is equal to, I think this will be exp of exponential t minus, let's take it as x square plus y square yeah, and we can also control this a into, and this is b into, and also we can control the amplitude. Let us take it as a into. So okay, so to be very precise, the z3 function is actually a Gaussian curve. So we have 3 functions over here. So we should also define the independent variables. X is equal to minus 10 is to 10, and y is equal to minus 10 is to 10. That's it. So once I defined it, I defined the independent variables. Now the thing is, when you want to plot a 3D plots using the surf command, it should be a 2-dimensional matrix. So to convert that, we have to use the for loop. That means how to put it in easier format is, if you see an Excel file, then column 1 row 1, so that should be x is equal to 1, y is equal to 1, means the x first element is minus 10, y's first element is minus 10. So corresponding to minus 10, x is equal to minus 10 and y is equal to minus 10, the z value needs to be stored. Then x is equal to 2, y is equal to 1, x is equal to 3, y is equal to 1. So in this way the entire data needs to be filled. So for that we can use the for command. So for I is equal to 1 is to length of x. Similarly for I is equal to, j is equal to 1 is to length of y. So I hope this is very simple. I'll take this, yeah. So this is just to have a very good format, that's it. And now z1 should be I comma j, x should be x of I, and y of j. Then z2 should be again similarly I comma j, and x should be I and y should be j. Now z3 should be again I comma j. Along with that we have here x is equal to I, x of I and y of j. Now we have even some controlling variables such as a. I'm putting a is equal to 1 for simplicity, and small a is equal to, let's take 0.02. I will say y 0.02 and b is equal to 0.02. However, these are mathematics, so I don't want to go in depth. Now our main aim is to understand the MATLAB plots, 3D plots. Now the 3D plot generation is completed. I mean, the 3D matrix for Z1, Z2, Z3 is completed. Similarly, we should also do for X and Y. So I will use the mesh grid. X comma Y is equal to mesh grid X comma Y. Now then we can plot the figures. Figure surf command, surf you can use. Then you can plot capital X comma capital Y comma Z1. So I'll copy this, Control C, Control V, Control V. I think 3 plots, right? So this will be Z1, okay, this will be Z2, and finally this should be Z3. Now this are 3D plots. Sorry, 3D plots. Now I just wanted to roughly explain. If you see, for I is equal to 1 is to length. So let us say we will start from the first loop. So it will be I is equal to 1. Then j, it will sweep j from 1 to the last element. That means first z1 of 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 till the 10th element, 21st element, it will sweep. It will store the elements for z1, z2 and z3. Then it will increment. I will increment to 2. Then 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4 till 2 comma 21. So similarly 3 comma. So in this way we'll get complete matrix of 21 by 21. So that is the logic. So similarly here the mesh grid also will convert this X comma Y to 21 by 21 matrix. Now I will run this. We will see if there is any error. Yeah, there is no error. The command has been successfully run. Now I'll plot all the 3 plots. Now you can see this is figure 4, figure 2 and figure 1. Okay, so now these are the 3 figures. Now as you can see, now this is if you want to get much more smoother figures, what you can do is, I'll just delete this, delete all the 3 figures. So I can also use a command called close all for closing all the figures. Okay, now what I can do is, if I want to have then I will instead of incrementing by 1, I will increment by 0.1. So 0.1. Now you see the plot will be much more, it is like sampling only. The sampling will be much more smoother. What happened? Sorry, this should be 0.1. Both dimensions should be same. Yeah, now you see it is much more smoother, right? Now figure 1, figure 2, figure 3. Now what I can do is view property editor. So similarly I will take all the figures, view property editor and view property editor. I have taken all the 3 figures over here. Now one thing what you can see is the figures are little bit dull. That means you can see that black lines over there. That is actually disturbing slightly. So to remove that, what we can do is, there is a command called, you have to go here and you have to use something called edge color. None. So I'm not going to delete those figures. So I'll keep those figures. Along with that, I'll plot another three figures, so that you'll understand the difference when we use edge color none, what happens. So I'll plot these, evaluate section. Now you can see. So figure 4, 5, 6 are without any edge colors. These are much more smoother, right, compared to that. view property editor, view property editor. Now that's it. Now I have got all the figures. I'll maximize it. Now if you move on to the first figure, so you can see because of this black lines it is not so clear compared to the fourth figure. Fourth figure is much more clear. So we will not use figure 1, figure 2, figure 3. So instead of using figure 1, figure 2, figure 3, we will use figure 4, figure 5 and figure 6, which are much more clear. So I'll just remove those 3 figures. So next, once we have done that, the concept would be same what we have done in 2D plots. First we need to arrange this properly. Sorry. And click here box so that you'll have all the lines over this. Then the edge color, that is, it should be white. The background should be white. Then here you have color map also. So in this color map you can use different things. The best thing for any plot would be, unless until you are working in something like thermal things, then you can use this hot figure or autumn figure in this kind of things. But if you are using something like fields, particularly I am working in electromagnetics, particularly in wireless power transmission, so I will use jet. So this is the best thing to plot. So similarly here I will go outside. Instead of this I will use jet. Similarly I will use white background. Here also the same thing. Sorry, go outside, use jet and white background. Now generally we want to plot all the 3 figures in the same location as we have done in the 2D plot. So for that, what we need to do, first we need to adjust the figures, carefully adjust the figures. Move to the left corner, yeah, and also change the font. This font needs to be changed to approximately 16, right? You remember, I hope. Now we will go here, we'll copy this and we will paste it here. Now this can be controlled. So we want till here and this we want till here. So we have one more figure, so we need to slightly adjust that. So for that we will actually shrink it much more. Yeah, this should be sufficient. Now we'll bring the third figure, copy and paste. We need to slightly shrink this so that it will get sufficient space. Yeah. Now in this way we can adjust all the 3 figures. Now I can move this little bit upward. Yeah, this is the perfect way. Now we have to maintain the symmetry in all the 3. So for that, what we need to do, first click the box, increase the font to, let us suppose 16. Similarly here also increase the font to 16. So these are the 3 plots. There are 3 different plots, 3 different functions. So again, insert text box. This should be A. (20) and I'll remove the line, none. Control C, Control V. this B, Control C, Control V, Control Z. Mistake. Okay. C. So in this way we have got 3 plots. Now we need to try to adjust the white space. So if you see in the top, there is certain white space which needs to be reduced. So in this way we can use the 3D plots. See, one more thing you can use is, you can, if you want, you can also use the color bar also. So you can also the color bar also can be adjusted, and top, bottom, it's up to you where you want it to use. So you can use even outside that. If you can bring it slightly down. So in this way you can adjust for all the 3 figures. Click on the color bar, then paste it outside this and slightly adjust it. Try to maintain the symmetry always. That is very important. Now here also you can put the color bar. So it is up to you where you want to use, how you want to use, that is up to you. Now using this color bar we can easily understand that the strength of this particular in the figure A, strength is very high at the edges. And one more thing is, we haven't given x-axis, y-axis. Let's take this as x of millimeter. I'm assuming this is in millimeter. Let us think these are the field equations. Y is also in millimeter. Let's assume the Z is the let us suppose electric field intensity E in volt per meter in this space. So let's take this as again x of mm, y of mm, then there is one more thing, that is Z. That is, let's just take this is also an electric field which is volt per meter unit is done. Now next the third one, let's take this as similarly x of mm. So the distance is in millimeter, minus 10 to 10, and also in both x and y axis. So with respect to distance, let us assume this is the field equations. I am not saying this is the field equation, I am just for example, as an exemplary, I am saying this is a field equation. So here we will take this as ampere per meter. So I hope this is clear. And one more thing I wanted to put it here is, you can see here it is only from minus 10 to 10, both x and y axis. You can control that, I already said you. So if you go to ticks, you can click here and you can press enter. So click here location -5, and the label also should be -5 over here. Click here insert 5, and here also you can put 5. Okay, so this is for x. Similarly you can go for y, do the same thing, -5, -5, +5, and +5. So in this way you can control, if you want you can control it. I'm repeating it always, you can control the x label and y label as you wish. Now you see it is minus 10 to 10 at an increment of minus 10, minus 5, 0, 5 and 10. Now this is much more better compared to what we are seeing in figure B. So in this way you can actually plot in a very good way. Now this you can share, you can actually what I say, you can save it in EPS file if you are using a LaTeX file. If you can also save it in a PDF file if you are using a Word file. So thank you. We will see the next videos in the next lecture.